रिकॉर्ड नहीं हुई ना? आप लोग भी थोड़ा ध्यान रखा करें इस बात का. सो वी आर डिस्कसिंग द क्लासिफिकेशन ऑफ igneous rock, and the classification is based on place of cooling of magma. Place of cooling of magma, we can divide it into two types. One is intrusive igneous rock. Intrusive igneous rock. Intrusive igneous rock. Another one is extrusive igneous rock. Extrusive igneous rock. Intrusive igneous rock as well as extrusive igneous rock. Intrusive igneous rock वे igneous rock हैं बच्चे when magma gets solidified. Magma gets solidified within the earth crust. Earth crust and below the earth surface. Below the earth surface. We call it intrusive igneous rock. While the extrusive igneous rock, when magma comes up on the earth surface, and get solidified, get cooled and solidified. It is called as extrusive igneous rock. Extrusive igneous rock. Fine. Extrusive igneous rock is of two types. One is explosive type. Extrusive igneous rock. Another one is white type. White. White. सही लिखा है? White type, silent type. Silent. That is what extrusive. And here intrusive, we have again two division. One is hypobasal. Hypobasal intrusive. Another one is plutonic intrusive. Plutonic intrusive. Okay. Hypobasal and plutonic intrusive. Let's take up this intrusive igneous rock, then we will come on to the extrusive. So intrusive igneous rock. Igneous rock, and it is of two types. One is deep-seated igneous rock. These are the crustal rock, earth crust, and there is magma that gets solidified. There is solidification of magma. So obviously there will be a magma chamber. This is the magma chamber, and the magma comes out and gets solidified much deeper in the crustal rock, much deeper. And such deep solidifications are called as plutonic igneous rock. These are what? Plutonic igneous rock. Plutonic igneous rock. And you know, there is a very slow cooling. Slow cooling. They are very deep inside the earth crust. Okay. Rate of cooling is exceedingly very slow. And that's why you will find very coarse grain. Very coarse grain. Very coarse grain igneous rock. What we call very coarse grain, pegmatites. They are what? Pegmatitic igneous rock. Pegmatitic igneous rock. Very coarse grain igneous rock. Pegmatitic igneous rock. And the best example, we have so many: granite, batholith, laccolith. So granites are the best example. Pegmatitic igneous rock, granites, they are plutonic igneous rock. Here it is earth surface. And they are solidified beneath the earth surface very deep. Okay, so very deep. So slow rate of cooling, क्योंकि अंदर जाते हैं आप बच्चे, आपने अर्थ इंटीरियर में देखा था, as we move inside, temperature is increasing. That's why यहाँ पे जो मैग्मा सॉलिडिफाई होगा, जाहिर सी बात है वो कैसा होगा? Solidification. Here it is slow cooling, very slow cooling of magma takes place, and very large crystals are formed, large crystals, and hence it is which type of rock? Very coarse grain, that is pegmatitic igneous rock. Pegmatitic igneous rock. Is it okay? Pegmatitic igneous rock. Next one is hypobasal. इंट्रूसिव में ही है बच्चे, दूसरा है. The second one is hypobasal. Hypobasal igneous rock. Hypobasal igneous rock. So this hypobasal igneous rock is what? Formation of this solidification of magma just below the earth crust. Means cooling of magma. Cooling of magma just below the earth surface, just below the earth surface. There is a cooling of magma that have taken place. And in this case, there is solidification of magma. Solidification of magma in different shape. In different shape. Okay. Just below the earth crust. So just below the earth crust, we have hypobasal igneous rock. And again, if we compare the grain, it is also of coarse grain. Coarse grain, but not as big coarse grain or bigger grains as in case of plutonic rock. So it is of, you can say, phaneritic igneous rock. Phaneritic type igneous. So we have phaneritic type igneous rock, quartz grain igneous rock. So we have visible, what you can say, grain, but indeed the cooling of magma just below the earth crust. So here it is the earth crust, and we happen to have a cooling of magma. Let's say this cooling takes place somewhere here, and it takes place like this. And once the various cycle of erosion eroded this, so we happen to have this kind of igneous rock exposed outside. Okay, so it looks like a mound, hill-like structure. Fine, of different shape. Like here we call it lapolith. Lapolith. So these are the igneous formation, intrusive formation, and of different shape. Let's find out the different igneous solidification, underground solidification. Okay, so it is intrusive igneous rock, and intrusive igneous rock gets solidified in different shapes, and on the very basis of those shapes they have been named. First one is batholith. Batholith. So batholith is a very large, irregular, irregular in shape, with undulating margin, solidified magma is called as batholith. Sometime entire magma chamber gets solidified. And it's a huge structure, काफी बड़े दिखाई पड़ते हैं. And when initial land was formed, these were the dome mountains, which was nothing but magma intrusion within the crustal rock. This was a magma intrusion within the crustal rock. Dome mountains bane bacche. These were the magma intrusion within the crustal rocks. Okay. For example, जब धारवाड़ सिस्टम बन रहा था, धारवाड़ system of rock were formed. At that very time, lots of batholiths were created. Batholiths were formed. Right now, we can have the example in India in form of Ranchi batholith. अगर आप चले जाएं झारखंड में, तो एक जगह है बच्चे, मुरहा पहाड़, which is famous Ranchi batholith, which is the best example of this irregular, wavy, intrusive magma formation. Okay, so Dharwad system of Precambrian orogeny. ये ओरोजेनी सबसे पहली ओरोजेनी है बच्चे, प्री कैम्ब्रियन ओरोजेनी. जिस समय ये सिस्टम्स बन रहे थे, ये वो समय था जब कॉन्टिनेंट्स बन रहे थे बच्चे, सॉलिडिफिकेशन हो रहा था मैग्मा क्रस्ट का और कॉन्टिनेंट्स बन रहे थे। तो यहाँ पे आपको न्यूमरस बैथोलिथ मिलेंगे धारवाड़ियन रॉक सिस्टम के नीचे एज अ dome mountain are what you can say batholiths. So Ranchi batholith dome. Apart from it, you can also find this batholith. Another example, Wicklow Mountain of Ireland. Ireland is the best example of batholith. So how batholith looks like? So this is the crustal rock. And here it is the magma chamber. From here magma comes out and it gets solidified like this. So these are the crustal rocks. So batholith from the interior of the earth means you can say plutonic as well as hypobasal, क्योंकि इसका upper part तो दिखता है. So these area were exposed due to several cycle of erosion. Several cycle of erosion. Now this upper part get exposed. This part get exposed. So these are the area which is exposed now. अब आपको ये एलिवेशंस दिखाई पड़ते हैं, ठीक है. तो यहाँ पे ये एलिवेशंस दिखेंगे, अर्थ सरफेस के ऊपर दिखते हैं, लेकिन इसका बेस काफी नीचे होता है बच्चे. बेस इज क्वाइट डाउन. So you can have the example, it's a hypobasal also and the base is what Pluton. तो इसके तरह के जो भी फॉर्मेशंस हैं वो काफी गहराई तक मिलते हैं बच्चे, जिनका नीचे का पार्ट प्लूटोनिक है और ऊपर देयर इज हाइपोबेसल. नाउ दिस लुक्स लाइक माउंटेन ऑन द अर्थ सरफेस. माउंटेन ऑन द अर्थ सरफेस, जैसे कहा मैंने विक्लो माउंटेन, मुरहा पहाड़. आप रांची में जाएंगे बच्चे, सो यू विल फाइंड बैथोलिथ. आप उसे देखेंगे तो आपको लगेगा ये माउंटेन है, लेकिन ये बना कैसे, ना फोल्डिंग है ना ब्लॉक माउंटेन है. और जब आप एक रॉक के क्रिस्टल्स को देखेंगे तो दे आर मेड अप ऑफ लार्ज क्रिस्टल्स. लार्ज क्रिस्टल अर्थ सरफेस पे तो बन नहीं सकते. इसका मतलब है ये पक्की बात है इंट्रूसिव रॉक फॉर्मेशन रहा होगा और आज ये एक्सपोज हो गया है बिकॉज ऑफ सेवरल साइकिल ऑफ इरोजन. सो सच रॉक आर डोम माउंटेन्स हैव द सेम स्टोरी. डोम माउंटेन्स बैथोलिथ को भी कहते हैं और लैकोलिथ को भी डोम माउंटेन कहते हैं बच्चे, जिसमें मैग्मा गेट सॉलिडिफाइड inside the earth crust but upper surface get eroded for due to several cycle of erosion. So one of the example is batholith. Another example is laccolith. Another example formation is laccolith. Laccolith. Suppose that this is the rock, crustal rock, and this crustal rock get elevated like this. Okay, these are the crustal rocks. And this elevation is due to intrusion of magma. Intrusion of magma. So this is the surface which looks like this. Right? This is the surface. But magma comes out. This is the magma chamber, and here magma comes out like this and gets solidified like this. There is a solidification of magma, and this solidification looks like this. There is solidification. So this is the solidified magma. Magma gets solidified like this. And due to this kind of solidification, dome-shaped solidification, the crustal rocks get lifted up. The crust is made up of maybe sedimentary rock or metamorphic rock or maybe igneous rock also. But beneath this earth crust, we happen to have igneous rock. This is what? Igneous rock formation. This is the crustal rock. And the shape is what? Dome shape solidification. This dome shape solidification is called as laccolith. Laccolith comes from a German word that is lacose. Lacose means lithos, that means rocks in dome shape. Dome shape. So rock in dome shape. Mushroom shape intrusion. Laccolith, they are mushroom shape, having convex summit and having gentle slope. Try to see gentle slope. Gentle slope. और बैथोलिथ में बच्चे gentle slope नहीं होता, abrupt slope है. ध्यान से देखो. If you see the batholith, try to see batholith. So here it is abrupt slope. Slope is abrupt. It's not gentle. While in laccolith, you will find gentle slope. There is a magma chamber. And here it is the vent. And we have this lacose formation or laccolith formation. Laccolith formation. Okay. So upper strata look like dome shape. This is dome. Gentle slope. Mushroom shape. Mushroom shape. Intrusive rock formation. And the best example is Henry Mountain. Henry Mountain of United States of America. Henry Mountain of United States of America. Next one is Phacolith. Phacolith. Phacolith में क्या होता है बच्चे? Magma gets solidified. Within the folded rock. Within the folded rock. Folded. अब कहीं folding हुई है. Folding का मतलब होता है ये बच्चे कि crust get folded and we happen to have a syncline and formation of anticline, syncline and anticline. This is, suppose that this is the folding that have taken place. Crustal rock get folded like this. So these are the crustal rock that get folded. Crustal rock that get folded. Crustal rocks that get folded. And this folding is because of the tangential force or any mountain building force. These are the crustal rocks that get folded. And there is supply of magma. And magma gets solidified. Magma reach to the folds and get solidified near the anticline. So there is a solidification of magma near anticline. This is solidification of magma near anticline and near syncline. Syncline, anticline and near syncline. So if magma gets solidified, if it get the places ना वहां पे जगह भी होनी चाहिए, and it gets solidified, in anticline as well as syncline. This is anticline. Here it is syncline. And there is magma solidification in this shape. This is what we call tracholith. We call it tracholith. Tracholith. And the best example is Corn Downhill. Corn Downhill. Corn Downhill is the best example of tracholith. Another type of solidification, intrusive solidification, is lopolith. And lopolith comes from, this is the fourth solidification, I think. Batholith, yes, fourth solidification. So lopolith, it again comes from a word, that is German word, Lopaz. German word, Lopaz. Lopaz means there is a basin. The meaning of Lopaz is basin. It's a saucer shape. Saucer shape, depression, base, Lopaz. Right. So there is a Lopaz, which is a bowl shape. You can say bowl shape, saucer shape, basin, and there is a solidification of magma where a basin is going to be formed. So this is magma that gets solidified. This is the magma that gets solidified like this. Shallow basin, not so deep. थोड़ा deep बना दिया मैंने. So it's not so deep. This is what magma solidification like this. Obviously, there will be some magma chamber, and the solidification is actually intrusive. So obviously, there are crustal rocks. These are the crustal rocks. And crustal rock के अंदर कुछ इस तरह का arrangement magma का हो जाए बच्चे कि there is a basin shaped solidification. This is what crustal rocks. And that is what called as lopolith. This is what Lopaz, right? And the best example is Bushveld lopolith of South America. South Bushveld lopolith of South Africa. अच्छा, याद रखना बच्चे, हम लोग इंट्रूसिव लैंडफॉर्म भी पढ़ रहे हैं. जब हम वॉल्केनिक इरप्शन पढ़ेंगे तो उसमें भी ये सारे लैंडफॉर्म आते हैं, तो वहां मैं केवल इशारा कर दूंगा. These are also called as internal landform created by volcanism. Internal landforms created by volcanism. Next is what? Sill as well as sheet. So what is sill? Sill का मतलब होता है ledge. Sill does mean LEDGE. ledge का मतलब होता है बच्चे एक प्लेटफॉर्म जिसपे आप कुछ रख सको, व्यवस्थित करके रख सको. It's a platform. So it's a horizontal platform. Horizontal. आप ऐसे समझ लो, एक अलमारी है, अलमारी में जो अलग अलग प्लेटफॉर्म हैं, दे आर कॉल्ड एज लेज. और इसी से शब्द लेजर बना है, जिसमें आपके अकाउंट्स बिल्कुल सुरक्षित रहते हैं. सो लेज, दैट इज व्हाट प्लेटफॉर्म, हॉरिजॉन्टल प्लेटफॉर्म अपॉन विच यू कैन पुट एनीथिंग. सो इट इज नथिंग बट द प्लेटफॉर्म. एंड व्हाट हैपन व्हेन देयर इज अ सॉलिडिफिकेशन ऑफ मैग्मा? So obviously there is a magma chamber, and from here magma comes out and it gets solidified in a horizontal manner. It finds a place within the crustal rock and get solidified like this, a thick horizontal solidification. Horizontal with respect to the crustal rock. These are the crustal rocks. These are the crustal rocks. Crustal rocks and horizontal solidification of crustal rock. These are called as sill. And they are thick, very thick. Means ranging from several 100 meters. This is the thickness. And once the upper part get eroded, it looks like this. तो ये जब ऊपर के crustal rocks erode हो जाते हैं तो ये कुछ ऐसे दिखते हैं बच्चे की. It looks like this. It looks like a sharp tableland formation on the earth crust. जब आप यहाँ आते हो तो आप इन्हें देखते हो कि ये फॉल्ट नहीं हुआ, न ब्लॉक माउंटेन है, न यहाँ पे कोई फोल्डिंग है. और अगर आप प्लूटोनिक रॉक देखते हो तो क्रिस्टल्स आर लार्ज क्रिस्टल्स. तब आपको लगता है कि अच्छा, ये जो रॉक्स बनी थी समवेयर इन जियोलॉजिकल पास्ट, दे वेर इंट्रूसिव, बट बिकॉज ऑफ सेवरल साइकिल ऑफ इरोजन they get exposed. अब ये ऊपर दिखाई पड़ रहा है. अब now they looks like mountain, and the best example is Great Wind Cell. Great Wind Cell of England. So it's a horizontal solidification of magma. And when this magma, and this the dimension is for several 100 meters height की dimension, और ये kilometers में हो सकते हैं बच्चे, spread in kilometers. This is the dimension. But once the thin solidification of magma, thin horizontal solidification of magma, we call it sheet. And there are several such sheets. Thin horizontal solidification, these are called as sheets. So thin horizontal solidification. Horizontal solidification. Solidification are called as sheet. Fine. Thin horizontal solidification, they are called as sheet. Okay. Another example is a dike. Dikes are vertical solidification. Vertical solidification. So vertical solidification. So these are the crustal rocks. And when the magma comes out and it gets solidified, vertical to the crustal rocks. Vertical to the crustal rocks. It may be vertical like this. It may be slightly tilted, maybe like this. So vertical solidification of magma with respect to the crustal rocks. They are called as dikes. Vertical solidification of magma, they are called as dike. And the best example, we have several dikes. Cleveland dike. We have Kuala Lumpur dike. And in India, we can see so many dikes near Bheda. Bheda Ghat is a place where Narmada is making water. There is a Dhuandhar water. Dhuandhar waterfall. Bheda Ghat in Jabalpur. And it is famous for several beautiful dikes over there. So vertical solidification of magma, that is what dikes. So Narmada river, Dhuandhar waterfall, Bheda Ghat. We have resistant dike, and there is a vertical igneous rock formation, vertical to the crustal rocks. These are the crustal rocks. So vertical solidification, horizontal solidification, right? And sometimes these vertical rocks get eroded and there is a depression created on dike or sill and water is going to be filled. So we call it dike lake or sill lake, etc. So इस तरह के lakes भी बनते हैं. That is because of exogenetic forces. Fine. Let's come to extrusive igneous rock. Extrusive igneous rock. Igneous rock. Again, extrusive is of two types. One is explosive. Explosive igneous rock. And silent igneous. Silent or quiet igneous rock. So explosive igneous rock, generally it is acidic. Acidic igneous rock. Because the acidic magma is thick. Is thick. And gets solidified. Right. In the vent. In the vent. During the time interval between two successive volcanic eruption. Between two volcanic eruption time interval में acidic जो magma होता है बच्चे, it is quite thicker. So this is the vent. And the thicker magma. It's a magma chamber. There it is the vent. And the magma which is acidic, actually it is what thicker. So this thicker magma gets solidified in the vent. So it gets solidified in the vent and it clogs the vent. So there is formation of lava dots, lava plug, and it clogs the vent. So the next explosion require more pressure built up inside, more magma, and that's why it is explosive in nature. Explosive magma. And when such explosion takes place, you will get huge amount of magma as well as pyroclastic material. So you will find this acidic magma is associated with massive explosion. Explosion along with pyroclast material along with lot of gases. So in general, these magma that comes out are with explosion because they are thick, they get solidified in the vent and they plug the vent, and that's why more and more pressure built up inside the magma chamber, and the next explosion is going to be catastrophic. Fine. And you will find that the cone of such volcanic formations are of narrow base. इनका base क्या होता है बच्चे? They are narrow base. Steeper slope is more than 30 degrees. Base is narrow. And if huge amount of lava comes out, so they have humongous height also. इनकी height भी ज़्यादा होती है. This is what explosive type of igneous rock. And silent type of igneous rock, अक्सर जो explosive type of igneous rock होते हैं बच्चे, they are coming from central eruption, and also they are on continents. कॉन्टिनेंट्स पे होते हैं बच्चे, है ना। while the silent eruptions, they are silent igneous rocks. They are actually coming from the fissures. So there is a fissure eruption, and here it gets solidified. Fissure eruption हो रहे होते हैं बच्चे, fissure eruption, and there is a basic magma, and this basic magma is highly fluid. So spread in a large area. And they create either basalt plateau or they create flood basalt. देखिए काफी दूर तक फैल जाते हैं बच्चे, और इनकी हाइट भी बहुत कम होती है. They looks like this. This is the magma flow. So there is a magma flow and you will find gentle sloping, and height भी क्या होती है, बहुत कम होती है. Base is quite broad base, and they are either going to form flood basalt or basalt plateau. And you can have best example. For example, we have Columbia Plateau. That is the best example of flood basalt. And there is the Deccan Plateau. That is the best example of silent igneous rock formation. Silent igneous rock formation, they are prone to weathering, better, they are prone to physical weathering. है ना बच्चे, फिजिकल वेदरिंग ज्यादा होती है और इनसे बन जाती है सॉइल, एंड सॉइल आर वेरी फर्टाइल. ओके, सो आपको पता ही है बच्चे, डेक्कन प्लेटो, you can see several lava deposits. Means Deccan Trap is not single lava deposit, several lava layer deposits can be seen. और अगर कभी आपको मुंबई से पुणे जाने का मौका मिले तो एक जगह पड़ता है खंडाला, और अगर आप वहां पे पहाड़ों को देखें, वेस्टर्न घाट की पहाड़ियां हैं, आपको दिखेंगी सेवरल लावा लेयर, डिस्टिंक्ट लावा लेयर कैन बी सीन, प्रोवाइडेड कि आप उन लावा लेयर को देख पाए जंगलों के बीच में. तो you'll find different lava layer that shows different period of volcanic eruption. Several lava layer, basic lava layer deposited over there. Cretaceous lava flow from Reunion Island. Reunion is a kind of hotspot. It's a hotspot. So do you remember this example, Deccan Trap? I will discuss the detail in later phase of the class. So this is all about igneous rock. And tomorrow we'll take up sedimentary and metamorphic. कल क्लास रखी जाए क्या? Tomorrow is Thursday. Tomorrow is Friday. कल क्लास रख लेते हैं. सैटरडे को थोड़ा मेरी एक्स्ट्रा क्लास रहेगी, तो सैटरडे और संडे को क्लास रख लेंगे. सो आज तो क्लास हो गई. थर्सडे फ्राइडे देयर विल बी क्लास होगी. सैटरडे को ऑफ रख लेंगे, फिर वी आर मीटिंग ऑन संडे. तो नेक्स्ट 2 क्लासेस ऑन फ्राइडे एंड संडे, ये 2 दिन हम लोग मिल रहे हैं. ठीक है बच्चे? So thank you very much for today. There is some question. So please share this notes. Sure, Deepak, I will share this in the Telegram channel. और कोई आज तो थोड़ा सा क्लास रिकॉर्ड नहीं हो पाई है, कम हुई है, बट ठीक है, मैं ये नोट्स शेयर कर दे रहा हूँ आपको. थैंक यू वेरी मच. आई एम साइनिंग. अविनाश 10 to 15 मिनट आफ्टर 9, तो 9:15 से मिला जाए क्या कल? ठीक है, रख लेते हैं 9:15. वी विल स्टार्ट एट 9:15.
सर एक क्वेश्चन था.
हाँ बेटे बताएं.
सर एसिडिक लावा लेस डेंस होता है.
थोड़ा तेज बोले बेटे. हाँ बताएं.
एसिडिक मैग्मा लेस डेंस होता है बट थिक ज्यादा होता है.
हाँ हाँ, ये बात सही है. एसिडिक मैग्मा, एसिडिक मैग्मा is less denser, but it is thick. आप पूछ रही हैं क्यों? और बेसिक मैग्मा more denser, but it is fluid. ये सवाल है ना बच्चे.
Yes,
So
sir.
density is because of the chemical composition. Acidic magma is more made up of silica. Silica is lighter, and due to it, there is density that is less. Basic magma, here we have more ferromagnesia. That's why it is heavier, that's why it is denser. But fluidity or viscosity is not at all depending upon the density of the matter. Viscosity depends upon interactions between the different layer of the liquid. अब अगर जैसे मान लो दिस इज different layer of the liquid, layer L1, layer L2, L3, L4, L5, L1, L2, L3, L4, L5. So whatsoever is density, if the interaction will be more, and interaction का मतलब weak interaction, there is hydrogen bond, van der Waal interaction ज्यादा होगा, तो ये लेयर एक दूसरे को फिसलने में रेसिस्टेंस पोज करती है. So the viscosity is something that resistance to flow. Resistance फ्लो होने में जो रेसिस्टेंस उत्पन्न करे उसको ज्यादा विस्कस कहते हैं बच्चे, उसको ज्यादा गाढ़ा कहते हैं. ठीक है. सो अगर रेसिस्टेंस ज्यादा होगा इनके लेयर्स में, यानी इनमें इंटरैक्शन ज्यादा होंगी, पकड़ ज्यादा होंगी, तो वो मैग्मा क्या होगा? थिक होगा. सो एसिडिक मैग्मा के अंदर जो लेयर के बीच में वीक इंटरैक्शंस होते हैं वो स्ट्रांग होते हैं. वीक इंटरैक्शंस आर स्ट्रांग. वीक इंटरैक्शन छोड़ दो, साइंस का टर्म है. इंटरैक्शन among the layer are stronger in case of honey. Honey देख रहे हो? Water and honey, compare water and honey. So honey has what? Thicker consistency because the layer are not free to move as compared to water, है ना? That's why honey is what? Thicker. अब आप कहोगे सर हनी इज डेंसर ऑल्सो, तो हो सकता है हनी डेंसर है, इस केस में तो है, वाटर कम डेंसर है, लेकिन लेट्स टेक अप एग्जांपल ऑफ मरकरी एंड आयरन. एट रूम टेम्परेचर इट इज इन लिक्विड स्टेट एंड हियर इट इज इन सॉलिड स्टेट, है ना? रूम टेम्परेचर पे डेंसिटी किसकी ज्यादा है बच्चे? आयरन और मरकरी में. मरकरी की डेंसिटी ज्यादा है आयरन से. Mercury is more denser as compared to iron, but it is in liquid state. तो इसको तो solid में ही होना चाहिए था as compared to density. So density is an intrinsic virtue that depends upon which element is going to take part, while the liquidity, or you can say fluidity or viscosity, is a virtue of the layer interacting with each other. If the layer are interacting with more interactions, more van der Waal interaction, more hydrogen bonding, or other weak interactions, so obviously they will pose resistance to flow, isn't it? And density is something that talks about which element is going to participate. You understand this?
Yes, sir.
ठीक है बच्चे. Shall I sign out?
सर
हाँ
एक और क्वेश्चन था
हाँ पूछिए.
कॉन्कॉर्डेंट इग्नियस रॉक और डिस्कॉर्डेंट इग्नियस रॉक क्या सिर्फ ऑकरेंस पे डिफरेंट है या फिर उसका स्ट्रक्चरल बेस पे डिफरेंट है?
That is what shape I think. Structure is different.
ओके ओके ठीक है.
हम्म. और कोई सवाल? So I'm signing off. Thank you very much.